to the video about how to make an exponential function based on 2 points. So I've given you the general formula of an exponential function, which you've seen before in our experiments in class and in the last video. And I just wanted to make a little note here that we do know some specific things. See this b value inside here? So the b is being raised to the x power. So that's the number that you're multiplying by every time in the table, right? You see what's happening. If it's doubling, that b value would be 2. If something was getting cut in half, that b value would be a 1/2. So if b is greater than 1, we're going to have exponential growth. And if b is between 0 and 1, and what I just wrote there says that b is greater than 0 and less than 1, in other words, it's between 0 and 1, that's when we have exponential decay. Just remember that, because when you get an answer, you want to check and see if that makes sense. Is something growing or is it decaying, and do you have the right type of value? So let's begin with an example. So I have 2 points here, and I have 0, 2, and 4, 162, and I want to make a exponential function that goes to those points. So in other words, if I were to make a quick graph of those points, there's 0, 2, and there's 4, 164, I want a graph that looks like this. So that's definitely going to be growth, right? So my answer for b better be greater than 1. And I want to figure out, well, what exactly b, like what should I put in? Should it be a 2? Should it be a 3? Is it a fraction? And that's what I'm going to help you figure out right now. And I really like this problem because it starts out giving you some free information. So this first point right here says 0, 2. 0 really means the starting point. So at 0, the value is 2. So 2 is our a value. So the a value is really the starting point, or in other words, it's the y-intercept. So we already have what a equals. It's our job to figure out what b equals. So here's what we're going to do. We know a, and we happen to know an x and y value as well, and that comes from right over here. We know that 4 is an x value, and we know that 162 is the y value that's paired with it. So we're going to plug in to this formula for any exponential function. Here we go. Right here for y, I'm going to get my y, 162. A we know is 2. B is what we're looking for, and x is 4. So now I want to solve for b. So let's see. I would have to divide both sides by 2. I'd have to undo this multiplication first. And if you need a calculator, go ahead, check that out. You get 81 equals b to the 4th power. That's how you say that. Now if that had been a b squared, you might think, well, I know how to undo squaring. I square root it. Well, how do you undo raising something to the 4th power, or an exponent of 4? You may not have ever done this before, so I'm here to teach you that that is actually also a root, but it's not the root that we're usually used to writing. We're going to call it the 4th root. So look, I'm going to put a little 4, a little itty-bitty 4 right there, and I'm going to call that the 4th root. So what we're going to do right now, there we go, and I'm going to ask the calculator to take the 4th root of something. Now I think you already know where the square root button is. I'm actually not going to use that button because that's for square rooting. And just so you know, a little note here, that when you square root something, that's the same thing as having a little 2 in that space. That's why it undoes squaring. So we're going to type in a 4th root right now. So I want to take the 4th root of 81. So I'm going to type in 4 for the 4th root. I'm going to go to the math button right here. And I'm going to choose number 5. Look at number 5. It has like a little X in that space. Notice it doesn't have a 4. And even though this looks like 4 times the square root of something, that 4, we really wanted to take the place of that X right up there. And that's all we're saying. So we want the 4th root of 81. And there it is. The answer is 3. And the 4th root of something to the 4th power gets you b, because the 4th root and to the 4th power are inverses of each other. So look at that. We have b, we have a. We can now answer our question. So find the equation of an exponential function that includes these 2 points. So here's my final answer. Y equals, let's see, 2 for a, 3 for b, and our exponent of x. So if you actually plugged in 0 to this equation, you would get 2, and if you plugged 4 into the equation, you'd get 164. Exactly what we wanted to get. Let's try another one. Notice I'm skipping number 2, and that's okay. I'm actually going to save that one for class if we have time. I'm going to do number 3 instead. And notice, instead of giving you the 2 points right away, I'm going to kind of hide that information in a word problem. We're going to have to figure out what the 2 points actually are. Alright, so in 2005, Miss Hoff's car was worth $5,000, and in 2008, it was worth $2,600. I think that information is going to help us with our 2 points. Write an equation in the form y equals a b to the x, representing the value of my car x years after 2005. Then determine when her car will be worth $1,000. Lots of stuff going on. Let's break it down. So let's go back to the beginning. In 2005, my car was worth $5,000. Those 2 pieces of information go together. In 2008, my car was worth $2,600. Those 2 pieces of information go together. Well, that sounds like I have 2 points. The first point, you might want to write down 2005 for your x value and 5,000 for your y value. I'm going to tell you that that's a really bad idea. And that's because over here it said, let x be the number of years after 2005. So we're going to call the year 2005 year 0, kind of the starting point of the problem. So I'm going to say the starting value that the problem gives us is 0, 5,000. Starting value. It gives us another value of the car in 2008. So instead of thinking of it as the year 2008, think of it as how long is that from the starting point? Well, the starting point, 2005, 2008 is 3 years later. So we're going to call this point 3, standing for 3 years since 2005, comma 2,600, the value of the car at that time. So there are 2 points. So what did I do in the first example? Right, this is my starting value is A. So I know that A is $5,000, and then I used this point as my x and y values in the equation to solve for B. So I'm going to do that right now. So we start with this, A times B to the x, and we're going to plug in a y. So I just said 2,600 for our y, 5,000 for our A, we don't know B, and we're going to plug in 3 for x, right? And that just came from these 3 places. But now I have to find out what B is. So I'm going to get B by itself. Here I go. First thing, I'm going to divide by 5,000. I'm not going to type that into the calculator. Look at this. It ends in zeros. I'm going to cross those out. So really, I'm going to type in 26 divided by 50. That gets me 0.52. if you typed it in with the zeros, you'd get the same thing, just so you know. And then over here, 5,000 divided by 5,000, that goes away, equals b cubed. All right, so now, how do I uncube something? Well, we did an example previous to this where we undid the 4th power, and we used that new button on our calculator called the x the root button. So I'm going to take the root, but I'm going to make it the cube root this time, because cube rooting undoes cubing. So here I go. I'm not going to show you on the calculator. I'm going to tell you, because you should remember how I did this. I type in the number of the type of root that I want. So I'm going to type in my calculator 3. Then I hit the math button, and I pick out that xth root, number 5. Now my calculator says cube root, and now I'm going to type in the 0.52, enter. And I got 0.80414511517. I'm just going to write the 0.804. And the cube rooting undid the cubing, so I get B. I have my B, I have my A, I am ready to write down my answer for the first question, which is saying write the equation. So here's my equation. Y equals 5,000 times 0.804 to the x power. So there it is. It's a decay function. The value of my car is definitely decreasing over time. I want to know when my car will be worth $1,000. So when will this function get me $1,000? That is what I'm going to plug in for y. When will this function equal 1,000? And the way that we solved that in the previous video was to graph. So I'm going to get my calculator out, and I'm going to graph in y1 the number 1,000, and then I'm going to graph the actual function in y2, so 5,000 times 0.804 caret to get the exponent of x. And I'm going to start my window out high enough to see 1,000. So I'm going to make my y max 2,000 and see if I need to change it. Nope, perfect. I can see that intersection right there. Let's find that. And I found my intersection. And don't forget, it looks something like this. The intersection is at 7.377, 1,000. There we go. And I'm going to answer the question now, when will the car be worth $1,000? So this represents the time in years. So it's 7 point something years since the starting point. So since 2005. So 7 years from 2005 would be 2012. So I'm going to write a sentence that answers that question. Here we go. Her car will be worth $1,000 in 2012. So now that you've seen an example given the 2 points, and an example where you have to find the 2 points, you should be fine trying the next few examples on your own. Good luck!